Hi, I'm Zainab. I'm going to be speaking to you on how your docs are a program. I'm conscious that it's towards the end of the conference, you've just had lunch, and you're not quite ready to be overblown with ideas. So don't worry, there will be many pleasant pictures within this talk. So I want you to imagine that you're back in the late 90s. You've just discovered the internet. You've just discovered not the vast information that you can find there. You're not inspired by how you can grow and develop. You've discovered cat photos. Right, you spend all day now looking at cat photos, browsing the internet, finding new cats. And you're so inspired by these that you decide to write your very own cat photo album. You write some code which will let you store your own cat photos. And this code has helped you so much in life that you decide, why don't I help everybody else? So you publish it as a library. And one day, you get all your friends together, your human friends, of which maybe there aren't so many. And you show them the cat photo library. And not surprisingly, they have some questions. One of them is an absolute cat lover. And he asks you, I'm itching to get started. How do I do that? Another one is a dog person. They're not quite convinced. They say, well, why? Why should I store cat photos? What's this big cat photo craze about anyway? Another one is like really hardcore into tech, and they've already checked out your code base. They've got your library as their dependency. And they're going through things, and they ask you, well, I've already added a photo to this album. How do I get the photo out? And by the way, this add photo function, what should I really be passing to it? Now, since you only have a few friends and they're right in front of you, you can just speak to them. You can answer their questions by sitting down, showing them the ropes, show them how you use the cat photo library. But soon, cat photos become really popular, and everybody else is using your library. And you're getting inundated with questions, some of whom are from people that you really don't know, some of those questions you don't even understand. And at this point, you start thinking to yourself, maybe I should write some docs. Maybe I should write some documentation so that instead of coming directly to me or just looking through the code base and puzzling through things, people can read that doc and figure out what they should be doing. Now, it turns out that there are different kinds of docs for different kinds of situations. Let's say that somebody first encounters a cat photo and they want to just get started with it. They might want a tutorial-like guide with step-by-step guide of how they could get started. Let's say that later this person who's gone through that guide, they go and they take a walk and they're walking their dog. On that walk, they might think to themselves, well, what really is the difference between a cat photo and a dog photo? Right? Why should I store just cat photos in this cat photo album? And they might use their phone and consult a different sort of guide, a conceptual guide. Let's say later after that walk, they get back to their desk and now they really know what they want to do with this cat photo album. They might benefit from a how-to for specific tasks. And if they're looking at very specific functions, they might want to look at a reference guide. Now, depending on what they're doing, what they're looking at, and where they are, they might be browsing these guides in different ways. Sometimes they'll be knee-deep in their IDE, and they'll want things to be surfaced to them that way. Other times, they'll be looking at your guide through a browser. They might not have even checked out your library yet. So depending on the kind of tool they're using to actually browse your documentation, you also want to write it in a slightly different way. Okay, so that was back in the 90s. Fast forward now to 2025, you decide, okay, it's finally time to write some documentation for cat photo. So you look around and you find that there are tons and tons and tons of tools that you could use. You discover that there's something called markup, but then there's also markdown, and there are tons of different flavors of markdown. There's Remark, there's MarkDoc, there's PanDoc. Depending on the language, there are different tools. Some people are now telling you that actually, no, you don't need to write any docs. You just pay somebody and they'll get an LLM to do it for you. And so, you might be very confused by this. Documentation is already pretty daunting, and the tooling around it is, in some ways, even more so. So what I'd like us to do over the next half hour is to take a step back from this, from all the tools and all the problems that are in this space, and start thinking about documentation in a slightly different way. I want us to start thinking about docs as programs. And I think if we start doing that, we'll begin to understand why there are so many different tools and different approaches to documentation. And we'll also be able to be a lot more creative in the way that we write docs and address documentation problems. So you might be wondering why, right? But why do I care about this? So I'm a functional programmer, or at least functional programming is one of my interests. I'm a Scala ambassador. What that means is that if you have any questions about Scala, you can come and ask me about them. There will be a little bit of Scala inside this talk, but you don't need to know any. But more than that, I'm also an educator. I write lots of training material, lots of docs, sometimes books as well. And I'm always a little bit frustrated about the documentation tooling that's out there. And since I enjoy programming, I like being creative. So we're going to think about docs in different ways throughout this talk. We're going to slowly ease into the idea of docs as programs. And the first thing that we can think about is docs as artifacts. So who's familiar with the term artifact? Cool, that's great, most of you. So by artifacts, we mean, if we were looking at source code, it would be something like a jar in Java, the thing that we produce, which we then go and distribute to other people by publishing it. So in order to try and illustrate this, let's imagine a scenario. Let's say we're writing some reference docs now for cat photo. We've taken a very specific function, the getPhoto function, and we've decided to document this. So getPhoto gets a random photo for a given cat. That's a little bit confusing, so in order to help people try and understand what it is they're doing, why don't we write a code snippet in here? We've got a code snippet which allows us to create a photo album, add a photo to it of Mal, who happens to be my cat, by the way. We can then get Mal's photo using the getPhoto function. This isn't the best example of docs, but we're not going to go into how to write docs. Let's just take a look at what happens to them. Okay, so our docs, if they're reference docs, are usually written alongside our source code. They get transformed in some way into something which looks a lot like, which is our API docs. Our API docs might be in different forms. They might be in HTML, so they can be viewable in a browser, or they might be in a different form that can be viewed via an IDE. Some IDEs can also go and directly look at the source file to find the API docs. So we have a pipeline here, which is very, very similar to the pipeline that we use to create artifacts when we are coding. So if this was a programming language, we would have some source files, let's say Java files. Those would go through some process, compilation, linting, perhaps, testing. And at the end of that process, you would get an artifact, you would get a jar, which you could use to publish to other people. And this transformation of source code into artifact, for all the languages that we really like, it's one that includes a lot of validation. We've mentioned a few things that we might want to do, right? We might want to compile our code, type check it. And the reason why we want to do that now, as opposed to later, is that we don't want it to be that when somebody's actually using our library that we publish, that the library breaks. Right? We want to try and detect bugs as early in the process as possible. And that's why we have all this validation. So we've got this validation for code. Can we have it for our docs as well? Well, our docs contain code. So if nothing else, we can at least try and validate the code that's within them. We're going to use a tool called doctest. And what doctest does is that it takes our code snippet that we've defined inside our documentation and converts it into a test. It actually produces a test file for the code that we write. And it checks that what we have written in our docs is actually correct. It checks that it compiles, but it also runs it and checks its output. So if we run doctest on this piece of code, it'll check that the result of getPhoto is actually mao.png. And you can do this via a build tool. In this case, we're using this SPT build tool, which you don't need to think about very much. Any build tool will really work. If we run our tests, we find that in this case, they succeed. So that's great, right? Our docs are good. Our docs are correct. Now, the good thing about this is that if we make a code change, let's say that we decide that actually getPhoto, it shouldn't just return a string. What if our cat didn't exist in our photo album? Let's return an option of a string. That means we're trying to represent the fact that our cat won't exist. If we do this, we make a change to the return type, but we don't actually change our code in our documentation, then our test will fail. And that's really great because we can now integrate these tests into our build pipeline. And so if our test fails, we can make our entire doc pipeline fail. So now we can correct this code, right? We can say that actually this is a sum. In this case, that means that we've changed the type. And our tests pass. OK, so now this is great. This means that every time we update our code, if there's documentation that actually references that code, it's going to compile, it's going to run, and we're going to make sure that it is what we expect. Well, that's for our reference docs, right? The ones that we write directly next to our code. Can we do this for other forms of docs as well? Now, if you have a guide, let's say a getting started guide, the language that you'll probably choose to write that in is Markdown. Who here is familiar with Markdown? Oh, that's great. So very, very quick intro. We'll be seeing a lot of Markdown. This syntax here means that we're defining a heading. This is a paragraph. Create a photo album. Here is a code snippet. In this case, we're saying that the code is written in Scala. So Markdown can be used to write documentation, which ultimately gets converted into HTML. It also has a pipeline, right? We take these Markdown sources, convert them somehow into a HTML file, and that later is published, and our users can view that via their browsers. So if there's a pipeline here, right, and we're producing an artifact, we can probably add some validation in there as well. And in fact, we can do the same thing. We can take the code snippets that we have, which are inside our Markdown, and we can try and run those. In order to do that, we're going to use a tool called mdoc. And what it does, well, how we use it actually, is that we just write this little mdoc keyword next to all the snippets that we want it to run. And it's going to go and run those and make sure that they are correct. Now, it turns out that if we do run mdoc on this piece of code, we get an error. We get an error because we've referred to this value album, but we've not declared what it is. Now, how many times have you gone online and you've come across a blog post or a tutorial and it refers to something, but it doesn't tell you where it got it from, right? It's so frustrating. So isn't it really great that we now have a tool which will catch that for us? It will actually run through the steps of our tutorial and check that they are correct. So we can go and fix this. We can add an import statement at the top of our getting started guide, which will say where cat photo is, or where album is coming from. And if we now run mdoc again, we see that it succeeds. So that's great. We can also integrate this tool now as part of our CI pipeline as well. So as well as running our tests, we can run mdoc as a documentation tool. Now, mdoc is more than just a tool to validate our code. It actually takes the initial source that you give it, and it will produce an output source. The output source will look very, very similar to the thing that you give it, except that it will have the results of execution. So in this case, we evaluated this statement, right, to create an album, and we got an album out of it. And this was what was printed to our REPL. Now, mdoc will actually insert that back into the markdown that it produces. And the really nice thing about that is that now when people are looking through this tutorial, they can see the expected output as well. So that's really nice, right? We can now process some of our input and display it in our output. What about other things that we may want to do now that we've got this pipeline of from our source to our artifact for our documentation? Well, one thing we might want to do is substitute variables. Let's say that cat photo is a really, really rapidly evolving library. And when you're publishing documentation for it, your documentation is always changing. Wouldn't it be really great if people knew when they were looking at your docs which version of the library those docs are published for? Well, we can do that by substituting a variable called version. So here what we're doing is that we're saying that we want to not write the actual version in our input source. We want that version number to be substituted. And we can use mdoc as a tool to, when we run it, insert that version number. And so now as our output, we see that that version number has been inserted. So not only can we validate our code snippets and print the outputs of our code snippets, we can also substitute variables. Well, what else can we do? So we've shown that we can display the outputs of our code snippets. What if we wanted to do something else with our output? For instance, this is documentation about cat photos, right? What if when we document get photo, we actually want to display the photo of the cat that we just got? So we can do that too by hooking into this mdoc pipeline using something called a modifier. So what we can do is that we can write a modifier which we're going to call display cat. It doesn't really matter too much about what this does, but it's going to take in the source code for our code snippet and the actual output of our code snippet and display it in a slightly different way. So if I were to use display cat inside my initial markdown, this is what it would look like. I would just write display cat, and that would mean that mdoc would go and it would take this display cat modifier that I have written and apply it to this code. And I've decided that what I want to do is when we use display cat, we're going to take the output of this code, which is going to be an image name, and we're going to insert some markdown for viewing that image. So that means that we can now not only just test and validate, we can also process the output that we get from our code snippets and display them in different ways. So that's how docs can be viewed as artifacts, right? They can be viewed as having a pipeline which will enable them to be validated, to be compiled, to be unit tested. We can integrate that pipeline into CI pipelines, right? We can now test our docs. We can do other things with it as well. We can try and do some variable substitution. And we can also, when we have code snippets, manipulate their output to display in different ways. So that's how docs are seen as artifacts. But docs can be other things as well. Docs can be seen as trees. let's take a step back and think about what MDoc is doing for a moment. And by the way, I'm showing you a lot of things about MDoc, but this really applies to a lot of documentation tooling systems that you see. We're taking our Markdown. We are splitting our Markdown up into blocks of text and blocks of code. And with this particular tool, we're only considering the blocks of code. We're producing another source file of just that code. And then we are using the programming language of that source, which in this case is Scala, to do the validation, right? To compile, to run, to test. So the way that we are validating the code snippets in our docs is to use the language that we are writing our documentation for, and use that language as toolchain. And we can do that because our documentation has some structure which lets us extract that code snippet. But Markdown has more than just structure for code. It has structure for everything else as well. It has structure for headings, right? For paragraphs. And some tools actually manipulate this structure too. So, for instance, you can, in some pipelines, take a Markdown heading and decide that you want to display it perhaps in a different way, or validate it in a different way. We're not going to look too deeply into this at the moment, but we should keep this in the back of our minds as we're looking at a few things later. Okay, so here's an example of the kinds of things, or rather ways of thinking about docs as trees. We know, for instance, that our Markdown gets converted into our HTML, and HTML has a tree structure, right? So it implies that our Markdown has a structure as well, right? A Markdown renderer is going to look at the structure of the initial Markdown, convert it into a tree structure, and then convert it into HTML. Okay, so we've seen how docs are artifacts, and thus we can add some validation onto them. We've seen how docs can be viewed as trees, and maybe then we can kind of manipulate trees. Maybe some of these documentation tools actually do that. But are docs code? If I showed you this file, would you be able to say confidently, oh, I'm writing in a programming language, right? Markdown is now a programming language because I can now validate it. I can compile the code within it. I can substitute variables. Who thinks yes? Yeah, so it's sort of like this, right? We're not really sure. And that's because, well, maybe it's a programming language, but if it is, it's not one that we really like, right? You know, the programming languages that we really enjoy working in, they give us a really nice, I think, confident feeling because we feel like we can understand their rules. But whatever we're doing, whatever pipeline we're building with all these different validation tools, they don't really have that many rules associated with them when they're all connected together. I'm going to illustrate a problem that we can't solve, actually, if we don't think about docs as programming languages. But we could solve if we could think about docs as code. So we've seen that our documentation, it has lots and lots of cat photos in, right? But we can't use cat photos without the consent of the cats, right? And the cats demand to be thanked. So as part of our documentation, we're going to write a thank you page, and it is absolutely vital that every single cat that we have a photo of or reference in our documentation is written in this page. Okay, so we have this list. These are the two cats. The two cats that you've seen so far are Mao and Popcorn. And we need to give them lots of treats. But let's say now, later, I'm going and I'm changing my guides, and I now refer to another cat. I refer to Cinder, but I've not I've not added Cinder to my thank you page, right? So this is actually a bug. And it is a bug that we see inside the text of our docs, which is not related to the code. When we've talked about validation so far, we've kind of been zooming in on just the code snippets that are in our docs, but actually there's a ton of other things, right, other areas that we could explore which are related to the text. Okay, so let's try and think about docs as code for a minute. If this was code, what would it look like? Well, I might have a thank you source file, and that might be a piece of source code. It might contain some functions. It might contain some variables. It might contain a list of cats, right? That's how we might represent it if it was code. We would have a getting started file, which would also be a source file, and maybe that would import some stuff from thank you. There would be this dependency going on. We would have a programming language and also a environment to run it in, such that when we actually executed getting started, we would evaluate the code within it. It would go and evaluate some code within thank you. There's lots of stuff actually that happens automatically when you code in a language like Java, which you don't really even think about, right? In terms of programming language rules and semantics, the way that they work, which you can't really get out of just Markdown. But what if you could, right? What if you could? And so this is really the idea of docs as code and docs as programs. There are ways, and I'm going to slowly disguise this way for you. I'm going to see if anybody will recognize this. So we've seen that our Markdown output is HTML. If we take HTML and we change the tags a little bit, right? I'm going to remove the tag at the end. What do we see? Yes, exactly. We see Lisp. So actually, there's a really big interoperability between, or rather relationship between Lisp and HTML. And you know, people hate coding in HTML, and some people hate coding in Lisp as well, but we're going to ignore them for the moment. We like coding in Lisp. It turns out that actually maybe the solution to this problem is to go to a Lisp. We are going to take a look at a language which is in the Lisp family, known as Racket. One of the reasons why Racket works so well is because of this kind of relationship, this nature of HTML as being able to be represented as a Racket list. By the way, if you have no idea what I'm talking about, do not worry. I will explain right now. Okay, so what is Racket? What is Lisp, or in this case, it's a scheme? It's a programming language. It's a programming language with lots of braces. Please accept the braces for the moment. We can define variables in it. This is how we might define a variable called myCat. MyCat is Mal. This is how we define a list of cats. Now, there are lots and lots of lists inside Lisp. A list is defined with a little apostrophe here. This is how we define a function, and yes, small brackets, I know. This is how we define the function stroke. And this here is how we call a function. We're calling the function string append. Okay, so that's a really quick whirlwind 101 of Racket syntax. In order to show you Racket, let's evaluate it. Okay, so we can enter the Racket REPL, which for some reason is displaying like this. I'm sorry about that. If we enter the Racket REPL, we can go and import this file using a statement called require. And we can then have a look at the symbols that that file exports. In this case, it exports a variable myCat. We can evaluate myCat, and we see that myCat's value is Mal. Right? That's like any other programming language, right? We can also call functions. We call functions like this. So here we have two parentheses to call the function stroke on my cat, and we're now stroking Mao. So he's getting very happy. But Racket is really, really cool for a different reason. It is a language that lets you write other languages. We're not going to write a language in Racket, but we are going to look at one. We're going to look at a language that has already been written called Pollen, and we're going to use it. Okay, so this is how we use a language that has been written in Racket. We have this #lang at the beginning. And then we write code. Is this code? Well, we'll see. I think this is code. And the reason why I know this is code is that I can evaluate it. So if I go into my Racket REPL now, I can require this file, so I can import the code in this file in the same way that I could import code that was written just directly in Racket. And if I do that, I see that there is a variable that it defines, a symbol that it exports, that I can have a look at. So Pollen is a language which is written in Racket. You write in it in something that's very similar to Markdown, and what it outputs when you evaluate it is a list, right? But it's a list that looks very, very similar to the HTML that we want to end up with. And in fact, it's trivial to just take this list and convert it into a big string of HTML that we want to put in a file. Okay, so this ability, though, to depend on code that was written in a different language in Pollen, depend on that code in Racket, and also do the reverse, by the way, is what gives Racket a really, positions it really well for solving this problem. So let's see how we might solve this problem. Okay, so we've seen that we had this thank you file, right? Let's go back to it a bit. This thank you file, which has a list of cats, and when we were thinking about our source code, we wanted to get that list of cats out, right? So we wanted to somehow have that list of cats usable by our getting started file. Okay, so now we know that if we use Pollen, that list is then evaluated into this list-like structure which has a load of li elements. And what we can do is that we can now start writing some proper Racket code. We can, in a new file, catname.rkt, import thank you, and we're going to use some helper functions to just select all the list elements that were inside the doc that it exported. And then we're going to define another function, let's call it catname. And what catname does is that it checks that a name that you give it, Mao, Popcorn, Cinder, is present in the list. And if it's present, then it says, oh yeah, we're all good, let's just return that name. Otherwise, we're going to raise an error. Okay, that's odd rendering there. Sorry about that. So we can actually use this. We can actually use the catname file that we've just defined inside our getting started file. So as I said, right, we've seen how we can call Pollen code from Racket. We can actually also call Racket from Pollen. So we can write require inside our Pollen code to go and get the catname file, and then refer to the catname function. OK, so now this is code. We're calling the cat name function here with a cat which isn't present inside our list. If we run this, we get an error. Our cat wasn't thanked. Cinder was not thanked. And so now we can go and we can fix this error. So we've added some validation now into our text as well. And we've done that by writing our text as code. We can think a little bit about how this looks, right? So we have our getting started HTML file, or rather, it was pretty much Markdown, but it was Pollen Markdown. That went and, when it was evaluated, called code which was written inside our cat name Racket file, which, when it was evaluated, went and called code that was written inside our thank you file. So we have this mix of code and docs. And if we wanted, we could actually just get rid of this cat name Racket file and write the Racket code directly inside the thank you file. It would look a little bit messy, though, so often it's quite nice to separate them out. So it's really hard, actually, to demonstrate the kinds of different things that you can do with this concept. So I'm going to just show you some examples of things that have been written, so to use that. So sometimes you might want to have code which is on a site which is quite difficult to explain, right? Wouldn't it be really cool if when we display code, we also display some kind of a reading guide to have with that code? This is something which hasn't really been done before, and I think it's really because we always think of code as something separate to text, right? We write loads and loads and loads of text, and then we write a block of code. And that's just the way that our tools are, right? The tools that exist currently don't allow us to do anything different. So this is something that was written in Racket and Pollen. It's walking through some code which is actually eLisp. We have a little description at the top of what the code does. And we can step through the code. There are actually some buttons that you can't see on the screen to walk through this code. And as we're walking through it, the description changes. There's some other stuff which is actually pretty cool about this code snippet. One is that you notice we were using parentheses before, and it was kind of hard to read all the parentheses. I'm pretty sure that some of you were really overwhelmed at the number of braces that were on the screen. Most of the time when you're coding in a Lisp-like syntax, you have syntax highlighting which is specific to the brace level of indentation you're in. So you can see, okay, this is an orange brace, that's a green brace, this is a purple brace. And that really helps you read the code a lot better. If you were to try and use a tool like Highlight.js, it won't do that for you. But it's actually pretty trivial to just write some code in Racket that will. So this is also something that was done via this interplay of markup and code. OK, so we've seen how docs are code. Does that mean that docs are programs? Well, I think what we saw was a lot closer to a programming language. In fact, it was effectively a programming language. But there's another aspect in which docs can be programs. And that is because when people are viewing docs, they don't need to view static HTML, right? In fact, there are a family of docs that already exist that are very prolific, which aren't static HTML, which allow people to interact with them. And those are notebooks. So a notebook is something which has blocks of text and blocks of code, and it allows you to actually evaluate the code which is in there as a user, and you can manipulate the code. This is an example of a notebook in Elixir. It doesn't actually, this example, display all the different things that you can do with notebooks. You can actually go in here and edit this code. right? Instead of getting a photo for Mao, I could go and get a photo for popcorn if I really wanted as a user. The reason we're demonstrating Elixir here is that Elixir has a really, really cool tool chain for how you generate these notebooks, which in Elixir are known as live books, from your documentation itself. So you can write documentation in Elixir, write reference docs even, and generate notebooks from them. Now, I really like notebooks, but there is a problem that I think people have with notebooks, in that if you're not familiar with the language or the ecosystem and you don't have everything set up, you're not really going to have some kind of local server to host your notebooks for you set up already, right? Or you're not going to have an account in some cloud provider that will let you go and browse notebooks. So I actually think there's a different way that we can achieve this same kind of interactivity and bring it to more people. And that is just to use our browser. So a lot of languages these days will be cross-compiled to JavaScript. It's a very common thing, right? In fact, in Scala, you can take most Scala code, and for any Scala library that you find, there'll probably be a JavaScript version of it. And that's produced by taking the original code, which is in Scala, and using a tool called Scala.js to produce a JavaScript module. So let's say that we're documenting some library, right? We're documenting some library, and our library is in Scala, and our library also is compiled to JavaScript as well. Wouldn't it be really cool if we could just take that JavaScript and embed it into our docs, so that when somebody's now looking at our HTML documentation, right, the thing that we're serving, and they're looking at it through their browser, they might not even have Scala set up, they might not have this library checked out, they just want to figure out roughly what it does. Wouldn't it be really cool if they could actually just run code written in that library? And in fact, you can do that. So this is an example of just that. This is a tool, one of the tools that I've written actually, for documenting a library in Scala. The library in Scala is for stream processing. We have a piece of code, and we have an input box for controlling one of the parameters to that code. And what's really interesting about this example is that this code is being run, but it's being run in somebody's browser. So there's no server in the back end which is going and taking somebody's code snippet that they've written and running it in some Scala environment. This is actually all happening in their own browser, which means that they can do things like type 100 right into their input box, and the only person that they're going to be upsetting is themselves. And that's very satisfying, right? Because when you're writing documentation, you really don't want to think about all the vulnerabilities that your documentation has. Another thing that's really nice about this is that we can actually use the kinds of the ideas that we've seen so far to draw a different version of what the output of this code is like. So instead of just displaying the output as some number, or in this case, some list, we can actually display the entire process of what's happening in the stream via a picture. Okay, so we've seen how docs are artifacts, right? At the very least, we can take the code snippets that are inside our docs, and we can go and start testing them. We can go and start validating them. We've seen that docs are trees. There are lots and lots of tools out there which will take a markdown document and convert it into some kind of tree structure and then process that tree structure. We've seen how docs are code. If you write them in Racket, then docs are code. I don't think that there's another language that allows you to do that. If there is, then please come tell me about it. And we've also seen that docs are programs, right? We can write docs which are interactive, docs which themselves are programs that a user runs. Now, you're probably thinking, right, well, where do you go next? Right, I said in the beginning, right, that you're inundated, you're overwhelmed with documentation tools, and I've shown you a few more documentation tools, and you probably don't use Scala, right? You're probably not going to touch Racket. I really hope you do. But what can you do? Well, what I really want you to take away from this is to think about your documentation tooling in a different way, right? Instead of thinking about your docs as just some text and some code, think about how you would solve problems that exist in them if they were a programming language, and try and think about the other problems that you encounter when you're actually writing them. So, yeah, you may not use these tools, but you may better understand the tools that are out there, and you may even write your own. I really look forward to the kinds of creative documentation that people will write if they start thinking in this way. Well, thank you very much. If you enjoyed that, you can find me on LinkedIn and Blue Sky. There's a book that I'm writing at the moment, which is in early access. What that means is that the structure is all there. Most of the content is there. It's probably not very well written yet, but it will be. And you can get 75% off with the code DevOps. So it is on this link. It's on Gumroad. If you just search functional stream processing in Scala and search for me, you'll be able to find it. Yeah, thank you very much. Thanks also to the cats that you saw.